Welcome, Hornets, and thank you for showing up today and listening to me and watching what I have to say. In this video, we are going over integration by limits, and we're working with quadratic equations. So you'll notice I have a list of integrals that are definite integrals involving quadratics, and we're going to be converting them into summations with limits as n approaches infinity. And then we are going to find the integral that is represented by that summation. All right? So we're going to be taking a look at number 2, and then I'm going to be doing number 4. Okay? And I leave the rest for everyone else to do, and I will provide the answers online. So we're going to start off with number 2. That is the integration from negative 1 to 2 of x squared minus 1 dx. And we have to start by figuring out what is our delta x. Delta x is the gap between negative 1 to 3, negative 1 to 2, which is 3 over n. And we are then going to, just a reminder, this is also b minus a divided by n. Gives you the same thing. And we're looking for our c sub I, which is the x sub I, or the x within this problem. And this is going to be my first term, negative 1, plus delta x times I. This is what we're going to put in. So you'll notice as we do this, we have the integration. Let's not do integration, we're going to summation. Here we go. So the limit as n approaches infinity, and I put my delta x in front. I like my delta x in front, but it can go directly behind the summation, or it can go all the way in back behind the function. And it's up to you. I like it right where it is. We're now looking at bracket, and I'm going to put in my 3i over n minus 1, the quantity squared, minus 1. Now, you'll notice how I wrote it in standard form. This is so that I can work with my binomial expansion, a squared minus 2ab plus b squared. So I have the limit as n approaches infinity for 3 over n. And now I'm going to just FOIL this out. 9i squared over n squared. 2 times 3 times negative 1 is negative 6i over n, and negative 1 squared is a positive 1, minus 1. Notice these cancel, and I'm now ready to begin the distribution of this piece to each. As I do, I'm going to be pulling out the 9 over n squared and the 6 over n in each term, and leaving myself with the I squared and I. So here we go. The limit as n is approaching infinity for 3 over n times 9 over n squared times the summation, I going from 1 to n of I squared, minus the limit as n approaches infinity for 3 over n times 6 over n times the summation, I equaling 1 to n of I. Now, as we talked about in the previous video, we're talking about limits at infinity. And because I already know that the summation of I, as I goes from 1 to n, is n plus 1 times 2n plus 1 divided by 6. Now, you'll notice this is going to give me a cubic where I will have 4 terms. A constant, a linear with n, a quadratic with n, and a cubic with n cubed. That's what happens when we FOIL and do this. But notice that I'm going to be multiplying by an n cubed. That means that all of the other terms, the constant, the n squared, are going towards 0 because the denominator will have a higher power of n. And for limits as n approaches infinity, when the higher power is in the denominator, the value is 0. So we're only working with, and I'm going to use n cubed over 3 for I squared, and for I, as I mentioned in the previous video, I'm using n squared over 2. Here we go. The limit as n approaches infinity for 27 over n cubed multiplied by n cubed over 3 minus the limit as n approaches infinity for 18 over n squared times n squared over 2. This gives me 9 minus 9. This area under the curve is 0. We're now going to check our answer by putting it into the calculator. We're going to start by just putting in math 9. We're working from -1 up to 2, and we're then going to put in x squared minus 1. We hit dx, we hit enter, and notice we get 0. All right, that is number 2. We're now going to be taking a look at number 4. Let's just remind ourselves what number 4 was, or you can look back at the worksheet for those of you who are in my class. We're looking at -2 to 1 for x squared plus x. We're going to start off in the same basic place. Write down the formula. We want our delta x. That's the gap between them. 1 minus -2 gives me 3 over n, or the gap between -2 to 1 is 3. C sub I, which is going to be my x sub I, is going to be the first term, -2 plus 3I over n. This is the x that we're going to put in now. So we have the limit as n approaches infinity times delta x, which is 3 over n, times the summation as I starts from 1 and goes up to n, of x squared, which is -2 plus 3I over n, the quantity squared, plus -2 plus 3I over n. Now in the previous problem, I set this up in standard form, and you might want to too. It does make it a lot easier for us to FOIL out that -2 plus 3I over n squared by writing it as 3I over n squared minus 2. Alrighty, this is going to give me the limit as n approaches infinity for 3 over n summation as I starts from 1 to n, and I'm now going to get the FOIL of this, and I'll rewrite that so that I can add like terms. 9I squared over n squared minus, for the negative, 2 times 2 times 3 is 12. Remember, it's 2ab. And then I have plus 4 minus 2 plus 3I over n. And we want to add like terms. So we have the limit as n is approaching infinity for 3 over n times the summation as I goes from 1 to n. And I have 9I squared over n squared minus 9I over n plus 2. We're now going to distribute this piece to each term, and as I do, I'm going to pull out the 9 over n squared and the 9 over n. Here we go. The limit as n approaches infinity for 3 over n, oops, that's a 2, and decided to write a 2, over n, times 9 over n squared, summation as I goes from 1 to n, and I'm putting in I squared, minus the limit as n approaches infinity for 3 over n times 9 over n times the summation of I, and then I have plus the limit as n approaches infinity, and we have our 3 over n times the summation, I going from 1 to n, of 2. So as we said in the previous problem, we're only replacing this with n cubed over 3. So I have the limit as n approaches infinity for 27 over n cubed times n cubed over 3 minus the limit As n is approaching infinity for 27 over n squared, and I'm replacing the summation of I with n squared over 2, plus the limit as n approaches infinity for 3 over n times 2n. We're now going to simplify each piece so that we can add them together. 9 minus 27 halves plus 6. Now you'll notice this is giving me 15 minus 27 halves, and if I get this into the common denominator, it's 30 minus 27 halves. I end up with 3 halves, or if you prefer, 1.5. Let's now take a look at our answer and make sure that we get the correct word that we want. And I think I have an error. Doesn't that fit? Where is my error? Just checking my work right now to make sure that if I have a mistake, I get it corrected. Twelve plus 3 makes 9. 2 times, yep, no, I've got it, and I do believe this is my correct answer. I'm now going to check my work. Here we go. If I made a mistake, it's going to be pretty obvious in just a second. As I do negative 2 to 1, I then put x squared plus x dx, and I get 1.5. So it is correct. Yay! All righty. So that was numbers 2 and 4 from worksheet integration by limits number 2. And I hope this has helped you. Thank you very much, and please be safe and take care and have a wonderful day. I hope all goes well. Please remember it's easy to be mean, so please be nice to each other. Actively work to be nice. And remember, change starts from within. We can't expect the world to become our vision if we ourselves are not trying to enact that vision by us and with what we do. Thank you very much, and be well. Bye-bye now.